A major branch of philosophy is taken to be what is called metaphysics or ontology, and I have to teach a selection for it, and I can start my selection from Plato in ancient Greeks 2004 years, 400 years ago, who said that so ideas or forms which are in everything, for example, the idea of table or the word table applies to any table, because that applies to anything that is general and that does not change from case to case. That is more real than particular cases which change from example to example. And I think if this idea or forms concept is of any use even today, and that can be for mathematics. For example, Plato could have given an example of a circle, and that circle is imitated, equation of circle is imitated by actual circles. So that's the general. And someone's there are two examples that they have made more specific specific cases for ideas. And Roger Penrose, who got 2020 physics Nobel Prize, he specialized ideas to mathematical ideas, and which he says they are in a mathematical world, which is one of the three worlds. And Popper philosopher says that the objective knowledge, which is knowledge independent of us, whether there is a knower or knower, or whether we are or not. These ideas form which is knowledge, which is independent of us. So these are the ideas which are still used today. And another one which is not which is actually used but not spoken as such, but everyone who doing science can know that in science we make a distinction between what is called accidental regularities and laws and rules of science, and that difference is because of an idea. And this is Plato. You can see Plato's idea or this idea. This time this science in other than Penrose, every scientist, whether realized or not, uses almost every science use the concept of idea of nature, which is a coherent system of regularities, which is not or symmetries. That's the last word is for physics, which is to be not same as accidental regularities. So I have to explain all things now in actual lectures. I start with Plato, and who said that Plato's own example is of if you see historical his book, then it's not apple, but it's a bed and table. But I'm showing you. I start with the apple because that is what I got a picture of that. And if you are interested more in history, then replace apple with bed or table, which I show later. Anyway, the same thing is there. If I take example of apple, the actual apple differ from one apple to another. So the changing from one apple to other apple, third apple, there's a change, and this change, Plato said that means it's not knowledge. The knowledge should not change. So what does not change is the idea of an apple, ideal apple. Okay, I say more when I show you wording. Plato said that you can say the word apple, or his own example, the word table, doesn't change from table to table. It doesn't change from example to example. That is the English translation, the best English translation which I have of his work is the word table. The idea of table is timeless. It doesn't change with time. It doesn't change with example. It's absolute. One example, another example, or third example, that applies to every. For example, the word table applies to every table. That doesn't change. This idea does not change from example to example. Another way of saying is, because I use slightly different words to introduce promised metaphysics and ontology. And for that purpose, I can say that when Plato said that the word table or idea of table means being table. And the being table is a characteristic which is in each example, in each table. Examples change, but this being table characteristic does not change. So now I can introduce you to the words metaphysics and ontology. Study of being is metaphysics, and study of is, what is. You know, the distinction is that is not what we know, what we see, not. Is means what is, whether we see it or not. So that's the difference. What we see changes from example to example. But the idea is there. You know, that's what Plato said. And what we see is another branch of philosophy which is called epistemology, our knowledge. Our knowledge is an imitation, that's a copy of the pure knowledge. Pure is also a term I show in the next slide. Pure means independent of examples, not changing with examples. But its imitation is examples. I mean, the imitation is actual, you can say, in this picture you can say actual apples, which we see. Plato's own word being actual table, actual particular table, which change from example to example. Because they change, so they are, in Plato's thinking, they are not real. Okay, that makes a clear distinction, because most of the people, I think I included that give more seriousness to what we see. So that's why giving more importance to what we do not see, that is a special branch of philosophy, and that is called metaphysics. And on metaphysics I have this the 9th lecture. And Encyclopedia Britannica says in the article epistemology that there are 4 major branches of philosophy. One is the metaphysics, which is this lecture. Another is logic, which I have covered in 4th lecture. Another is ethics, means the study of the word should. You know, should, I have told you in 3rd lecture, the should is not is. Should is not a description. That's a normative, I said. These kind of things I said in the 3rd lecture. And I plan to say more on justification of should on my next lecture, 10th. So that is toward the 3rd branch. And the 4th branch is epistemology, that knowledge, what we have it, we see, then we form theories, and we mean human beings. And that is, in my opinion, is so important that except for, you can say, 3 or 4 lectures, all of my 11 lectures in total, 8 lectures, almost more than 8 lectures are devoted to what is called epistemology, study of human knowledge. So that is the whole plan of the full course, of the full philosophy. Now I remain specialized to today's lecture, and that means I said ideas which are, no, I have spoken the word pure for ideas, but I have not defined what the word pure means, and now I do now. In my opinion, this Plato would have been more useful in today's time if Plato has used the example of a circle rather than table. Because tableness, or the word table, or the common idea of table is not used, it's at least much less used than the common idea of circle. There are many circles. This picture may be something like a Plato's time, and Plato would have seen many circles, and this is a very good one. In that time, you can think of 400 years ago, you can make a circle on a sand by your hand, and obviously that circle is not the actual circle. You can say the actual circle is what we today know as equation of circle, or even Plato could have, I think he must have known it, that the idea of a shape whose all points have same distance from center. So this idea, if Plato gave that idea, that is, and applies that to whatever circle was available to him at that time, and so that idea would have been much more useful than table or whatever he said it, because this idea is what we use today. We use today to make pictures by computers of a circle, and that our computers use an equation of a circle, which is an equation form of this condition that all points of the same distance from the center. An equation means mathematics. So all in all, what I'm saying is that mathematics is the idea that Plato should have said it. And anyway, leave aside history. Today, if you are in search of a usefulness of pure ideas, pure means Platonic, and which, but the term pure means Platonic, I mean it practically. But if you ask me about the word pure, that word, the phrase is not due to Plato, but that is due to Immanuel Kant. I think it was toward the end of 18th century and start of 19th century. But there's a major book, Critique of Pure Reason, and that's why I have picked up the word pure. That was the end of 18th century. And pure, the another word of Kant for pure is a priori. And a priori means, you can guess the word prior means before. Before, or, there are details I don't have time to explain. So the minor differences you can ask me separately. Here I'm taking the pure as before, same as independent. At least that's I take or not, this is Encyclopedia Britannica. The entry a priori gives that a priori means Kant's term for knowledge which is independent of any particular experience. The particularity I have to explain in the next lecture. For the moment, you take if it is independent of or before. The difference between independent or before, that is also a topic of my next lecture. So for the moment, you just take it. Idea is anything, whatever you call it before, you call it independent. That is also another way of saying it. That's a condition of any experience, and that has to be before. But before you do any experience, before observation, you must have in Kant's terms, you must have a structure inside you, and that structure Kant said is a structure of space-time. So anyway, what I mean to say is that in addition to Plato, I can include some things from Kant as well in my list of pure ideas. And pure means independent of, or you can say before any particular observation, which is above here. And that was also like an apple. It was independent of actual apples. That's a circle is independent of actual circles, and mathematics is independent of our observations. So this so far I have something, and now I include more. And I mentioned Penrose before, but Penrose is one scientist, and I think in actual my lecture I make a different order. I introduce the idea and pure idea, and I hope you understand the word pure now. A pure idea which is used by almost any scientist, including Penrose. Penrose I specialize to next slide. So now go to any scientist or almost any scientist, he or she uses an idea that scientific rules are not accidental regularities. They are not only separately isolated regularities. An example of separately isolated or accidental regularity is like all crows are black, or all pieces of gold are less than 10,000 tons or so, which is a regularity seen, but it has no. It misses a quality which is the accidental regularities, which I said about crows or gold pieces. They miss a quality. Now that this quality cannot be seen, and that's why that's why I call it this quality as pure idea, and that's why I have included in today's lecture. Now, so today, this pure idea, which is scientists think that which is in their equations or rule, which is not only regularity but something more than regularity, and that is the scientists think that they are not describing, making a list of regularities, but they are trying to understand their own most common word I think would be they are trying to understand nature. But if you ask me what is the definition of nature, then I have to admit this is, at least I have to admit that this is not a very clear term. Clear as I have a title of my channel, Clear Thinking. So by that standard, nature is not clear. What, if you ask me for a clear term, then I would say what I said earlier in comparison to accidental regularities, that scientific regularities are coherent system of regularities. That to me is a clear. There are many, if you say any accidental regularity, any other accidental regularity, for example, the color of crows and the color of any other bird, they are not related, they are not consistent, they are not matching, they don't form a system. But scientific regularities and scientific laws, different scientific laws, they make a consistent system which you may or may not call it nature. If you think it's clear, you call it nature. If you think it's not clear, don't call it nature. But anyway, what is there, that is the coherent, consistent system. And that's a system is a system, it cannot be seen. So that in that sense it's a pure, it's not that. But that system idea or nature is I think in mind of almost every scientist. And they think when they think of a new idea, they think that this is imitated by down to, it's not down to earth, I should say. It's a down means visible, which is actually seen, and actually seen are scientific equations. Actual scientific equations, not idea of science. Idea of science is one thing, is everywhere, and now we imitate, we express in terms of particular science equations. So that's another use of ideas of science, is also a pure idea, and pure I have explained much, and I think I should not repeat again. I go to now specialized to one particular scientist, and which is Roger Penrose, who got Nobel Prize in 2024 years ago for his work on black holes. And what there's a book, The Road to Reality by Penrose, and in that Penrose talks about three worlds. One is the physical world, which in physical world means you have if you go to today, like the physical world is different apples, different, even if they are changing, whatever. The physical world has different tables, I said, tables, even if they are changing. And then the scientific experiments and all this and that. That's the physical world. And then is the mental world. And mental world is we actually think. But mental world is different for different persons. But Penrose says that there is a mathematical world which is different to mental, in that the mental world is different for different persons, but the mathematical world is same for all. Circle equation in mental world, in physical world you can make a circle of different shapes. In mental world, different persons can think of a circle of different sizes or different uses. But the equation of circle, that is for everyone. That's the distinction between mental world and Platonic world. And the same thing as the philosopher of science called Popper said, objective knowledge. And your objective means I said it universal, but you call it objective, call it universal. That means that for everyone. So that means it's not changing from mental life. The Penrose, Popper also says physical and mental, but replaces mathematical word with objective knowledge. I think Popper's objective knowledge includes math, because objective knowledge is which doesn't change with the mental, different person to person, but every person is a universal idea. Knowledge which you study in books, and the books are, academic books also, which everyone studies, and the normal usage terminology is objectivity. So that is, these are the ideas, and I think if you think the physical world can be actual, after observation, but this mathematical or objective knowledge, they are independent of, you can say, before any actual observation, and they are, in that sense, they are pure. Okay, now this I said this scientists have this idea of pure nature, or that pure nature idea was expressed in a physics Nobel laureate words. The Nobel laureate is Paul Dirac, and Dirac said that it is more important to have beauty in one equation than to have fit experiment. Now, the beauty in an equation is, in my categorization, is not a clear phrase, so I postpone comment on that. For me, the major concern of this my course or this topic is that whatever something is there, whether you understand or not, this is more important than experiment. So that means that you can say it's independent of experiment or before experiment. In that sense, it fits in today's lecture. Something is there which is before experiment. So that's, in that sense, it's pure. But anyway, having said that, for completeness, I should try to understand this word beauty in equations as well. And for that, what I did a search and found through Google is that Dirac has also said that I consider that I understand an equation when I can predict properties of its solution without actually solving it. I try to explain to you what Dirac means, but before that, I would like to point out that when you solve an equation, you make a prediction. And in your prediction, you verify by actual observation. So that means that's an actual observation. But before solving means is independent of prediction or independent of actual observation. And that means pure, if you understand this terminology. So that means first you try to get you the where the whole thing fits in my lecture. But if you are you want me explaining what predicts the properties of a solution without actually solving example of it, then I can say it, so that at least you don't remain puzzled. And that is that that's only physics students need. I think others can skip that thing. Other can remain content with what I've sought so far. But a physics student may like to say, because that's the subject, Nobel laureate Paul Dirac. So they say, what did he say? And I think my effort to understand is that predict properties of a differential equation without actually solving it. A differential equation is Newton's second law. And Newton's second law has t square. That means if you replace t with minus t, it's a solution. Even before finding solution, you know that the solution will not change if I change t to minus t. Physicists call this symmetries, and they have ability to recognize good physicists, and they have ability to recognize symmetries before solving it. And I think that maybe Dirac meant that. Now, before ending lecture, I have to say that this is just a feeling or whatever was expressed by Paul Dirac. But when I say it's not clear, you can't clearly define beauty. So if you want to stick to the standard of clarity, and I think for that, I think I would like to include a quotation from another physics Nobel laureate, Feynman, which I already spoken about as well. But at this moment, for comparison, I think it's necessary that you don't forget that whatever you think of a beauty of equations or whatever it is, if your implications or results of your ideas, maybe beauty of equation or so, does not agree with the experiment, it's wrong. So that means so what I mean to say is that in today's lecture I've spoken about things independent of experience, but because people like to say that, it's because of others. If you ask me, then whatever I said, I would like to end with saying that that does not mean that importance of experiment is decreased, and that I think that remains there. Now you can finish it here, you can leave it here, but those physics students who may have become confused that why are two physics Nobel laureates saying things which are apparently contradictory to each other, so is there not any common standard to physicists? If that is the question, Then I answer, which maybe can be understandable only to physics students, and others can may or may not stick for 2 minutes more, and then I have to finish. This is the last of it. To physics student or maybe to others as well, if you understand, I say I must clarify that these kind of disagreements in physicists especially become prominent when you have made experimental discovery, but and that maybe contradicts old theory, but people say that the experimental discoveries remains to be checked again. So some people are convinced of experimental results even now, and some say that we are not presently convinced, and you have to repeat it again. And but if it is repeated again and again fails and again fails, and eventually if it is established that something is against experiment, then I tell you, every physicist, whatever is or her way of saying it, no physicist would clearly make clash with any experiment which is established. But before getting established, there will remain a controversy. Some people will say, for example, physics students know the Michelson-Morley experiment of 1887 that contradicted Newtonian physics, and then but it took something like 1887 to, you can say, first 20 years of 20th century as well, something like 30 years of a demand to repeat it again, check it again. So at that moment, it was a crisis, and eventually this crisis eventually resulted in a revolution in physics. The old physics of Newtonian and Maxwell was replaced with the modern physics of relativity and quantum mechanics. So that's in this period you can see that there can be a serious difference of opinion, even if eventually no one denies experiment. So for acknowledgement, I should say that the terminology of crisis and revolution which I've used, that is due to Thomas Kuhn, and I have more on Thomas Kuhn in the next lecture. So that's all I have in today's lecture. Thank you for watching.